Alright, what you're about to see, this is the first time anybody is doing this. It's part of our Mmanu series. Now, see, whenever we're talking about circular motion, we know that in kinematics, motion has to do with displacement, which is S, velocity, which is V, acceleration, which is A. Now, when we are talking about linear velocity, we know that S is S. But in angular velocity, I want you to know that you don't use S, you use theta. So everything you are going to be doing in angular displacement, when you talk about in angular motion, whenever you put this, always put R. So theta stands for displacement, and linear motion, S is displacement. So for angular velocity, for angular motion is going to be theta R as, or should I say, functioning as S. So S, what you call the relationship between S in angular motion is that S is equals to theta, product of theta and R. Now velocity in linear is equals to S over T, right? Yes, you know that. Yes, you know that. But here, the relationship between linear velocity and angular velocity is simply W. This is called angular velocity. W is the symbol for angular velocity or speed. Put R to it. This is the symbol. This is the formula for velocity. The relationship between the two. This is also, this thing you see here is the formula for tangential velocity. This formula you see here is the formula for velocity. Which means that if I make W subject of the formula, W is equals to V over R. You need to know this. Another thing you need to know is that acceleration does not have its own symbol, or like something we'll call maybe angular acceleration. It's always dealing with velocity. So just say W square. That is angular velocity square. Now put R to it. So everything is always carrying R. So as I put it this way. So which means that if I want to find, so this is the relationship. This is also called linear acceleration, or you say tangential acceleration. No, don't call it tangential, but this is linear, or you say it's the relationship between acceleration, linear acceleration, and angular acceleration. So if I want to get centripetal acceleration now, I can simply say A, or should I say, I can say A is equals to W square R. And remember that W, from what we've done here, W is equals to V over R. So this is square. Now R. So if I do V square over R times R, and this is in square, remember this is squared, this will cancel this, so that I have that A is equals to V square over R. I tell you, nobody has done this before, and I want you to know it now and practice with it. So it's part of our Mmanu series. Thank you. Share, subscribe.